Good afternoon, and welcome to Great Paul Visionary Tutor online course. This day we want to look at proof of this particular question, and we can prove this by mathematical induction, by induction method. So we go. It is when k is equal to one, you see that it is trivial. When k is equals to one, then it is trivial. Now, but let's consider the situation when n is equals to 2m minus 1, that is odd. When m is equal to odd, so we have, and then we consider k equals to k plus 1, that is n is equal to k plus 1. So we have, the equation becomes 1 plus 2k plus 1 minus 1 all over 2m minus 1. This one now, we can we have can have we play this over 1, and we have 1 2 raised to power k plus 1 plus 2m minus 1 minus 1, then all over 2m minus 1. So this is what we have. This one is equal to this. When we put k plus 1, that is, when we have k plus 1, then we have n is equal to 2m minus 1. So we have this, and this one becomes, if you look at it, you can write this as 1 all over 2m minus 1 times 2k plus 1 minus 2m minus 2. Now, if you divide by 2m and multiply by 2m, so we have 2m all over 2m minus 1 times 2k plus 1 minus 2m minus 2 all over 2m. 2 is common here. We have 2m all over 2m minus 1 in times 2 is common, so we have 2k. This is times 2 raised to power 1. Then we have 2k, 2 into 2k minus 2 minus m minus 1 all over 2m. So this one we cancel this. Then we have equals to 2m all over 2m minus 1. Now, this one, we have this one divided by this. This one should be plus, 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 plus. This one divided by this, we have 1 plus, then we take these two, 2k minus 1 all over m for this. Then you can, if you use this one to divide, you can divide this. You can use this to divide this also. If you use that to divide, we have 1 minus 1 all over 2m minus 1. Sorry, plus. We will give a plus into 1 plus 2k minus 1 all over m. This is what we have. It implies that 1 plus 2k plus 1 minus 1 all over 2m minus 1. This one is equal to this. That is the implication. Then also, you can still solve this. You can still solve this. 1 plus 1 all over 2m minus 1 into this one. You can rewrite it as 1 plus, multiply both sides by 2, and multiply this one by 2, divide by 2. So we have 2k plus 1 minus 2 all over 2m. That is what we have here again, which is equals to 1 plus 1 all over 2m minus 1 into this one. Let's find sm is 2m. We have 2k plus 1 plus 2m minus 2m bracket this. So we have, you can write this as 1 plus 1 all over 2m minus 1 into, you can multiply and divide by this. We have 2k plus 1 plus 2m minus 2 all over 2k plus 1 plus 2m minus 4, then times this one, 2k plus 1 plus 2m plus minus 4 all over this. You can see this one can still cancel this. This one can cancel this. We get this back. So, but you can write it as 1 plus 1 all over 2m minus 1 bracket. Now, this one divided by this. If you use this one to divide by this, we have 1 plus 1 plus, you can see that 2 is common. 2 is common here. We can write 2 into bracket 2k plus m minus 1 all over 2 into 2k plus 2 plus m minus 2. Then multiply by 2 is also common here. 2 into 2 raised to power k plus m minus 2 all over 2m. 2 we cancel 2, 2 we cancel 2 here. So we have 1 plus 1 all over 2m minus 1 into this one, if you use this one to divide this, you have 1 plus 1 all over 2k plus m minus 2 bracket bracket 2k plus m minus 2 all over m. So this continue. So from here also we can get 1 plus 1 all over 2m minus 1 bracket 1 plus 1 all over 2k plus m minus 2. Now m is count. This one can count. So this we have 1 plus we take this one and this one 2k minus 2 all over m. So this one continue like that. So we can say that if m1 is equals to 2m minus 1, if we take m1 to be this and m2 to be 2k plus m minus 2 and m3 to be m. So we can continue like that. This is continuous products. So then we can also test for the when n is equals to 2m, which is even. Then we now conclude our proof that induction, this one is true. Thank you.